Welcome to this demonstration of message transmission using the Pluto Software Defined Radio. My name is Jihyun Seo, and in this project I will showcase how we can transmit and decode a simple message wirelessly. Here is my Pluto SDR device. The Pluto SDR device specifically supports frequencies from 325 MHz to about 3.8 GHz. And allowing both transmission and reception of signals. It's widely used for education, research, and even hobbyist projects, making it ideal for this demo. As you can see from this device, the one on the left side with the antenna is a transmission side, which transmits the data to the receiver side on the right side. Using the Pluto SDR, now we're going to wirelessly transmit a message and see if it is correctly received and interpreted on the other side. At the core of the digital communication is the transmission of bits, the fundamental zeros and ones that encode all the information we share today. Instead of sending the message as a plain text, we first convert it into a series of bits using ASCII encoding. This creates a bit stream that can be efficiently transmitted on the code you can see here. As you can see, I am trying to send the message "I like you," but we cannot actually send this message as itself. So we first encode into the bits and then make a bit stream with zeros and ones so that we can efficiently send it throughout the TX. The modulation technique we're using in this project is 4-com, or quadrature amplitude modulation. 4-com is an efficient way to transmit data, balancing energy efficiency and bit rate by encoding 2 bits per symbol. This means we can send more information with fewer resources. Now let's see how this works step by step. We'll start by encoding our message, modulating the signal using the 4-com. So the signal is already modulated with the 4-com here, and this part of the code is required to interpret the code correctly depending on which com we have used. The higher com you want to use, the more energy you are required. So in this case, we're just sending the message, so we don't need that much efficiency or the power. So I chose the 4-com. After the modulation, the receiver will try to decode the signal, interpret the bit stream, and reconstruct the original message. As you can see here, you can see the highest peak in the cross correlation, and that's how we find out the correct starting point of the data. And then after we correctly find out the starting point, we can plot the IQ constellation. But this is before the channel correction. So as you can see, the points on the IQ constellation, they are not correct place. So we are doing some kinds of techniques to correctly estimate and correct the channel. After we correct the channel, you can see the data are separated into 4 regions. And we can use this data to correctly interpret the original bits. Now, all you need to do is correctly demodulate and decode those bits into a message correctly. So as you can see from the demodulated bits here and the transmitted bit here, they are exactly the same because their bit error rate is 0.0. So we're going to use the techniques of the demodulation as we did in the TX side to encode them into bits. We try to demodulate the bit stream into ASCII code, and then using the ASCII code, we are going to correctly decode it into a message. So the decoded message from the demodulated bit is same as the TX side, "I like you." So in the demonstration, we have successfully showcased the power of the Pluto SDR device in wireless communication, from encoding and modulating the message to transmitting and decoding it. This project highlights the potential of SDR technology with wireless communication. This success encourages further exploration in the SDR projects where possibilities are virtually endless. With tools like Pluto SDR, we can move from simple message transmission to more complex tasks like transmitting images, which involve significantly more data. And thank you for watching the video, and stay tuned for our next project where we'll tackle the transmitting image wirelessly. Until then, happy experimenting.